All right, this is a geometry class, so this example is going to deal with proving statements in geometry. If an angle is an exterior angle of a triangle, prove that its measure is greater than the measure of either of its corresponding remote interior angles. So let's remind ourselves what a remote interior angle is. So if this is your exterior angle number 1, the remote interior angles are 3 and 4, the ones furthest away. They're in a remote location. Okay, they're further away. The diagram models the situation. Identify what you are given and what you are asked to prove. So we know that 1 is an exterior angle of our triangle, and we want to prove that it is greater than either 3 or 4. So we're going to assume that it is less than or equal to either 3 or 4. So our first thing we have to do is contradict the hypothesis. The measure of angle 1 less than or equal to the measure of angle 4 means that either measure of angle 1 is equal to the measure of angle 4 or the measure of angle 1 is less than the measure of angle 4. So we're first going to look at the measure of angle 1 being equal to the measure of angle 4. What that means is the measure of angle 1 equals the measure of angle 4 plus the measure of angle 3, which is our exterior angle theorem. We know that that has to be true. And if 1 is equal to 4, then we can replace 4 with 1. So now we're saying that the measure of angle 1 equals the measure of angle 1 plus the measure of angle 3, which means that the measure of angle 3 has to be 0. Well, we know that in our triangle, none of our angles are equal to 0. So this cannot be true. This contradicts the fact that the measures of any angle of a triangle is greater than 0. So the measure of angle 1 cannot equal the measure of angle 4. So then we move to the second case, where the measure of angle 1 is less than the measure of angle 4. By the exterior angle theorem, we know that the measure of angle 1 equals the measure of angle 4 plus the measure of angle 3. Because angle measures in triangles are positive, the definition of inequality implies that the measure of angle 1 has to be greater than the measure of angle 4. And that contradicts the assumption that the measure of angle 1 is going to be less than the measure of angle 4. The argument for the measure of angle 1 less than or equal to the measure of angle 3 follows the same reasoning. In both cases, the assumption leads to a contradiction. Therefore, the original conclusion that the measure of angle 1 has to be greater than measure of angle 4 and the measure of angle 1 has to be greater than the measure of angle 3 must be true. Watch out. Remember that the contradiction in an indirect proof does not always contradict the given information or the assumption. It can contradict a known fact or definition, such as in case 1, that the measure of the angle must be greater than 0.